Hello everybody, Chaz Large here with another video for you, and on the bench today we've got a Sony cassette deck, quite a nice one. It's a K461s, and the complaint is that it doesn't record properly on one channel. It's intermittent on one channel. Done a couple of quick tests and just had the lid off just to make sure that everything was all in place, there was no loose wires or anything. Anyway, let me show you the fault. So let's just power it on. Well, if I turn it on, it'll work a lot better. Let's power it on. Right, so yes, the fault is that there is intermittent recording on one channel. So let's just show you that it's working. Powered on, and we've got the indicator on the display. Put our test tape in, press playback. I've just got headphones in at the moment, just don't want too much noise. There's no headphone level control on this deck, which is a little bit disappointing, but anyway, it's got a lot of other features. But you can see on the screen there that both channels are playing back okay. Good stuff. Right, next thing to do is to do a test recording, and what I've done is I've connected up my test signal generator with a twin phono into left and right inputs. Got a blank tape here to do a recording on. Press the record pause, and we can see that we've only got output from on the left hand channel, and if I turn the record level up, we can see that. Now I've got a record balance control there. I can turn that fully to the left, and I've got maximum signal. If I turn it fully over to the right, goes over there, and I can't hear anything on the right hand channel. So simplest way of doing this, if we have a look at the circuit diagram, is we'll follow through the path, the signal path from the input. So starting with the two connectors that are at the back here, let me just go to the overhead camera and you can see exactly what I'm talking about. So we've got the two phono inputs there, and I've got the oscilloscope, which I will put up on the screen as well. Okay, so I've got a scope on screen now. I'll just move that out of the way so that we can see what we're looking at. Can't make it any smaller than that, but basically I'm going to put my scope earth on the chassis here. It's a good tag here. And on one input side, I can see an input. Let's just go onto scope and change the input level. Got that to 1 volt, 200 millivolt peak to peak. So there we have an input on one channel. And there we have the input on the other channel. So both input channels are okay, so we know the socket's okay. So looking at the circuit diagram, we can see that the input comes in from the two channels down here through IC511, which is the input buffer. So IC511, which is this one here, and it should be two inputs on pins 2 and 3 and 5. So we've got our scope. Take the clip probe off. 1, 2, 3. So there's the input on one side, and 4, 5. That's the input on the other side. So they look both the same. That's good. And then the outputs from that comes from pins 1 and 7. So there's pin 1, that's good, and 7 is good. So I think we can discount the buffer. The signal seems to be the same going in and coming out of the buffer. From the buffer, the signal now goes down this line into the connector CN504. That takes us through into the panel board, which is the front control panel here, and through the two balance and record level controls and back out. So they go in and then they come out. Let's check the output, it's easier. Pins 5 and 7. It's a little bit difficult to get hold of. That's this ribbon cable, so I'm just going to pull this ribbon cable out just very slightly. What I'll do is I'll just take the camera down so you can see down here. So what I'm going to do is just gently pull the ribbon cable out just slightly to show a little bit of the ribbon, because the shiny side is on that side. So 3, 5 and 7. Now it's gone out of focus, this camera, it always does. It's not the autofocus part of it. So, and on the board we've got pin 1 at here, so we've got 1, 2, 3, 4, 5 is there, and we've got a lesser signal there, so let's just turn the scope gain up to say 50, 20 millivolts. There it is. Not making a particularly brilliant connection with that. 1, 2, 3, 4, 5. So there's 1, 6 and 7. So that and that, they look the same to me, so I'm going to discount the front control panels. On the circuit, going back to the circuit, from those connections it comes across and then down into the analog mode switch. So it comes down into here, this is IC506, and goes in on pins 5 and 2. From 5 it goes through the switch and out of 4, so if it's going to be the switch we should be able to see something on 4, and into 2 it comes out on 15, so 2 and 15 is what we should be looking at. IC506, which is this one here, I believe. Yeah, there it is. 1, 2, 3, 4, 5 and 15. Is that right? Let's just double check. Have I messed it up? Yeah. Into 5 out of 4. 4 and 15. 4 and 15. There we are. So 1, 2, 3, 4 is one output, and 15 is the other. There we go. So from 4 and 15 it comes out of those two, goes up to here, and now it's going into the Dolby noise reduction amplifier. So one channel comes up, goes through R204, C202 to pin 3, and this one goes through those two components to pin 26. So 3 and 26 is where we want to look at on IC501. So IC501, there we are. 1, 2, 3. We've got nothing. And 26, 28, 27, 26. Aha! We have a signal on 26, but we have nothing on number 3. So pin 3 is fed through C202, R204. Let's have a look. So there's C202, there's R204, so let's go on to R204. Signal there, signal on the other side. Yes, signal on the negative side of that capacitor. No, nothing. Nothing on either side. That's weird, isn't it? So, is it? It is doing it. Let's just double check we haven't lost the connection. So definitely on that resistor, R204. And there's that capacitor there. Nothing on there. Nothing on there. So I suspect what we've probably got on there, on this board, is a broken trace somewhere between that resistor and that capacitor. So it looks like we're going to have to take the board out to see where that is, because that's where we seem to have lost the signal. So let's disconnect everything, power it down, power down there, and start a dismantling. So dismantling of this, now if I remember rightly on these, let's just get rid of the scope capture for a minute. The circuit board for the tape deck pushes into these connectors, so the best thing is to undo all the ribbon cables, undo that one from the mains transformer. We make sure we've unplugged the mains transformer from the mains, because there's no switch, there's live mains sitting on there, so you need to be very careful with that. Let's get rid of those headphones for a minute. Less clutter makes a better working space. So undo all the ribbons, screw on the back of that socket. Yeah, there's 3 transistors clamped onto there, so we can undo that clamp to loosen that off and slide the front panel away. So let's do that. I've done a few of these before, and there's this screw here that's also holding the deck in place. So we should now be able to gingerly, oh, there's another, okay, well, let's pull, I don't like pulling the wires. Let's just get our plug puller on that. So we should now be able to gingerly disconnect the deck, there we are, from there. I think I'll take this earth screw off as well. Okay, so now we've got, so the PCB is held in place by clips. So again, my plug puller will come in handy because it's got 2 little lugs in there. Just push them close enough. Slide up that clip, and one more clip, and we've got the circuit board out. Well, I can see the fault straight away. Now I've got that up. It's just sort of jumped out at me. Let's switch it to this other camera here so I can give you a better close-up. Okay, well, I can see the fault straight away. It's fairly apparent to me, but isn't perhaps to you. But if I turn the board just slightly, can you see this here? This is the capacitor. Let's just flip it over. The capacitor there, C202. And what's happened is that capacitor has been knocked, and in doing so it's broken the trace just there. So the trace from that resistor to that capacitor, that's what's been broken. So there we have found our fault. So what I'll do is I will remove that and clean this board off and make a new connection with that, and that should fix the fault. So let's see if I can do that on camera. Had a little bit of a upset with my OBS system, decided to crash and die, so managed to get it all back working again. Now hopefully this camera will attain focus and stay in focus, and we will put this board, yeah, in fact I think I should be able to just wipe that, but actually I've still got the bit of the land. No, it's come off. Thought it might. So that basically has got to, I think I'll just hit a helping hand with a edge of a screwdriver. Just use the 5p now. I might be able to just bend the leg of that capacitor over to meet that board. That print. So yeah, it seems to go there. Let's just push it out of the way again for a minute and tin that. Track. Move that capacitor over. Bend it down. Give it a wiggle. Seems to be in place. That'll do for me. No point in adding extra bits and pieces to the board where it's not necessary. That capacitor is going to be there nice and solid. Obviously at some stage or other somebody's obviously gone into here, banged this capacitor, or perhaps in production it was done, banged, and it's just been making and breaking. Perhaps some vibration has caused it to finally fail. And reassemble. So we've got three transistors there. There's no heatsink compound on any of those, so they're not likely to be ones that are going to be drastically overheating if I don't put any in there, so I'm not going to put stuff there that wasn't necessary. Just drop the board into position, push it down on the clips, make sure they're all done up, put the heatsink clamp back on there, so that's a little plate of metal that holds those three transistors against there, and let's start putting some screws back. Now, just out of interest, if you take one of these apart, you may notice, if you don't take great care, that one of these screws, or two of these screws, are very much shorter than the others, and they're the screws that come through onto the bottom of the deck. There is one, and the other short one is for the ground earth there. So they're the two that you don't use to go in the back of anything else. Learnt that the hard way myself one day. So that's that, and we'll pop the deck back into place. So part of that just drops into the metalwork. Pushes down. I can turn that over. So a short one into here. If you put a screw that's too long into this position, you could foul part of the mechanism. Now, one thing wrong with this little screwdriver, it's a brilliant little screwdriver, it's got no torque setting, so just do it up nearly all the way and finish it off by hand. Then you won't damage something. Don't forget this earth as well, because it's the earth in the middle of the, or the ground rather, in the middle of the balance and record level controls, and if you don't get that right, you'll get an imbalance between the two channels. So that earth is vital that you put that, make sure you get that in. And that all appears to be back together. A nice easy repair this one. Let's connect my signal generator to the input. Didn't quite tighten that screw up in the middle there, did I? There we go. Alright, over to the bench wide. So we can now plug it in. Power it on, power on there, we've still got a tape in there, got a signal on there, press the record pause, and we've got record on both channels. And we can go up on one channel and down on the other. Well, that seems to have fixed it. Just a broken leg of a capacitor effectively, or the print on the bottom of that leg of that capacitor, stopping one channel from working. Hope you've enjoyed this little video, bit of signal tracing. Hope you have success if you're doing similar sort of things. Thanks very much for watching. Cheerio.